Okay, good morning students. So we discussed in last class, what is the friction, types of the friction, so methods of decreasing friction, okay, so which is the easier to the through the or land roller, okay. So now today discuss the some problems so that is calculate the time needed for a net force of 5 newtons. Okay, net force 5 newtons to change the velocity of the 10 kg mass of by 2 meter per second. Got it? So calculate the time needed. Okay, calculated the time needed, and so the net force 5 newtons. Net force 5 newtons to change the velocity 10 kg of mass by 2 meter per second. Okay, got it. So now to find out the time needed. Okay, so that by using the equation F is equal to ma. F is equal to ma. Okay, so F is equal to ma and m is taken, so mass of the body, so mass of the given body, m is equal to 10 kg. Okay, 10 kg, and so change in the velocity v minus u is equal to 2 meter per second, and force F is equal to 5 newtons. Okay, so given information, so that is the mass of the body 10 kgs and change in the velocity v minus u is equal to 2 meter per second and F is equal to 5 newtons. Got it? So according to the Newton's second law, F is equal to ma and m. So a, by using the kinetic equation, so v minus u is equal to at. So a is equal to v minus u by t. Okay, v minus u by t. F is equal. Okay, so now taken that is equal to m. M is now substituting is 10. Okay, v minus u. So v minus u is equal to, okay, 2 meter per second. Okay, so to find out the time, and F is equal also given, so that value is 5 newtons. Okay, right. So now 5 is equal to, so 10 into 2, 20 by t. So 5 1 ja, 5 4 ja. So time t is equal to 4 seconds. Okay, time t is equal to 4 seconds. So the time needed for net force 5 newtons to change in the velocity 10 kgs of the body, okay, mass of the body, and by 2 meter per second. So given information, mass is the 10 kg and change in the velocity. Change in the velocity E is final velocity minus initial velocity. So v minus u is equal to 2 meter per second. And now net force F, it will be applied 5 newtons. So v minus u is equal to at. So a is equal to v minus u by t. And so according to the Newton's second law, F is equal to ma. A is nothing but acceleration. So acceleration is changing by using the kinetic equation. So v minus u is equal to at. So a is equal to v minus u by t. And get substituting, and so now get the final value, that is the time needed, t is equal to 4 seconds. Right. So now discuss the another problem. A constant force acting on a body of mass 3.0 kg changes its speed. Okay, it is a speed from 2.0 meter per second to 3.5 meter per second in 25 seconds. So the direction of the motion of the body, remains unchanged. Okay, so what is the magnitude and direction of the force? What is the magnitude and direction of the force? Got it? Now, so by using and given information, so first of all, mass is taken, so 3.0, okay, m is equal to 3.0 3 kgs. Got it? Now, so changes in a speed from 2.0 to 3.5, changes in a speed. Okay, now time is taken 25 seconds. In the direction of the motion and remains unchanged, and what is the magnitude and direction? Got it? Alright, so by using the according to the Newton's second law, F is equal to ma. F is equal to ma. So m and a we can write similar pattern here also like that. So v minus u by t. Okay, m is the mass of the body is 3 kgs. Okay, v minus u and the final velocity minus initial velocity and 3.5. 3.5 minus 2.0 by 25 seconds time. Got it? Now, so 3 into 3.5 minus 2.0, 1.5 by 25. Okay, so now we calculated, we get the final equation, final answer 0.18. Okay, 0.18. So the constant force is acting on a body, so mass changes the speed. Okay, so the direction of the motion of the body remains unchanged. What is the magnitude? 0.18 in the direction of the force. In the direction of the force. Okay, right, got it. Okay, now, so discuss the another topic is what, so derive the Newton's second law, F is equal to ma. Okay, right. So according to the Newton's second law, so F is directly proportional to dP by dt. Newton's second law, F is directly proportional to dP by dt. What is the P? Momentum. Okay, so the rate of change of the momentum, is directly proportional to the, so the net force or resultant force is acting on a body in the direction of the force. Text plus direction of the force. Got it? So now once again repeat. So the P is nothing but momentum. The change in the momentum. Okay, change in the momentum is directly proportional to the force is acting on the body. Text plus in the direction of the force. So we can write in mathematically. So F is directly proportional to dP by dt. Got it? So now derivation of the F is equal ma. Okay, F is equal ma. Now according to the definition, F is directly proportional to dP by dt. So P is equal momentum. P is equal mass into velocity. So F is directly proportional to dmv by dt. Okay, so F is directly proportional to, so m is the mass of the body is constant. So remaining equation we can write dv by dt. Okay, according to derivation of dv by dt is equal acceleration, because the change, okay, the change in the velocity is equal acceleration. So now substituting equation, F is directly proportional to ma. Okay, dv by dt is equal a. So proportional neglected, some constant are taken, that is the k ma. If k is equal to 1, okay, F is equal to ma. Okay, F is equal to ma. So F is directly proportional to dv by dt. So what is the momentum? Already we know that momentum is nothing but, so mass into velocity is called as a momentum. So mass into velocity we can write. Now substituting in the equation. Okay, so constant we can write so m dv by dt. What is the mean of the dv by dt? So change in the velocity is called acceleration. Okay, so a value substituting in the equation. So F is directly proportional to ma. So proportional neglected, some constant are taken, that is the k. K is called as the proportionality constant. Okay, proportionality constant. So if k is equal to 1, so we can write F is equal to ma. Okay, so the mass of the body is taken 1 kg or 1 unit. So acceleration is taken also 1 unit and net force is also 1 unit. Okay, so that is equal to 1. Okay, so find out the units. SI units is taken, okay, joule. Okay, SI units are joules. That is nothing but force. Okay, so the dyne is taken CGS units, force. Okay, SI units is joule, CGS units are joules to find it. Okay, so now another topic is taken, that is the laws of rolling friction. Law of rolling friction. So what is the rolling friction? So the rolling friction is, so one body is rolling to the another body. Okay, one body or one rolling body. Okay, so rolling to the another body is called as a rolling friction. The contacts between is called as a rolling friction. So the rolling friction, law of the rolling friction. So when one body is rolling to the another body, okay, so the contact is called as a rolling friction. Okay, so the law of rolling friction, so the smaller area of contact, the lesser will be rolling friction. Okay, so smaller area is very small. Okay, so the rolling friction will be less. Okay, so what is mean? Smaller area of contact. Smaller area of contact. So contact means so attachment. Okay, smaller area. So smaller area of attachment is called as a, okay, so rolling friction is less. Now another word is the larger radius. So larger radius of the body, so the contact will be less. So less friction. And so now another taken is the rolling friction. Third law. So the rolling friction is directly proportional to the normal reaction. Already so discussed in a land roller topic. Okay, so the rolling friction is directly proportional to the normal reaction. So rolling friction, okay, Fr is directly proportional to the normal reaction. So Fr is equal to mu r into n. So what is the mu r? Mu r is the coefficient of rolling friction. Coefficient of coefficient of rolling friction. So Fr is equal to mu r into n. So the first law is a smaller area of contact. Smaller area of contact, less rolling friction. And now the second one is the larger radius. Okay, larger radius also contact is very less, so that one is also okay. So smaller area, so larger radius, so will be okay. So having that means so lesser rolling friction. Now another also taken, the rolling friction is directly proportional to the normal reaction. So Fr is directly proportional to the normal reaction. So Fr is equal to mu r into n. So mu r is called as a coefficient of rolling friction. Okay, got it? Right. So now discuss the another topic of work, energy and power. Okay, what is the work and what is the power, what is the energy and what is the work energy theorem and what is the potential energy and what is the kinetic energy. So discuss the another topic, another class. Okay, thank you students.